All right, welcome back to Unit 7, lesson number 5, or lesson number 4, 7.5. We are going to be looking at the laws of logarithms. So just like exponent or power, we have exponent laws. For logarithms, we also have laws. Okay, so just rules that we should know. Before we start, however, we're going to quickly review what we did last time. Okay, so I would like you to try these 3 questions just to evaluate these 3 log expressions. All right, so hopefully this is what you got. Again, to solve or to evaluate these log expressions, you need to first make all these logs into like just an x, and then change into exponential form, and then you can solve the exponential equation from there, and then you should be able to evaluate each one of these log expressions. Okay, hopefully that's what you got. So now we're gonna be looking at these 6 statements here. They are all true. Okay, these 6 equations, they are all truth. Okay, there's no all of them are equal to each other. Okay, now I would like you to figure out what's the rule here. Okay, so think about it. Okay, hopefully you notice some patterns here, at least for the you can see these two should go together. You can see this was log 2 plus log 3. Again, if you're not sure, if you don't believe in me, you can absolutely pull out, you could definitely pull out a calculator. Okay, there is a log button on the calculator you should be able to find. You can put that into the calculator and you should see that log 2 plus log 3 is definitely equal to log 6. And log 5 plus log 12 is definitely equal to log 60. So based on these 2 examples, hopefully you see that this 6 and this 60 really came from 2 times 3 and 5 times 12. Okay, so that's the first rule that we have. The laws of logarithm is that when x is greater than 0 and when y is greater than 0, the product law says that log base b of x times y, this can be split into log base b of x plus log base b of y. Of course, I mean, you could also say log base of b of x plus log base b of y is equal to log base b of xy. It's the same thing, right? It's not just going one way, it's going both directions. Okay, so we call this the product law. Again, the key is the value of b, the base has to be bigger than 0 and it cannot equal to 1. The second rule that we should be able to notice is the second set of numbers right here, or second set of equations. Log 8 minus log 2 is log 4, and then log 50 minus log 2 is log 25. Hopefully you notice that the 4 and the 25 came from 8 divided by 2, 50 divided by 2. Okay, so here's the quotient law. Log base b of x over y really is the same thing as log of base b x minus log base b of y. Okay, so that's the quotient law. Now, one thing that I think people get confused, I guess, or made mistake is the second one here. Usually people, when they see this, okay, again, this is a common mistake that I see people make, is that once they see this, they think this is log base b x divided by log base b of y. Okay, so be careful. It's not the division of the logs. It's the division of the x and the y. Okay, so be careful. Be careful. Okay, that's a common mistake. Okay, now the third set of equations right here. Now you might be able to see what's happening here. You might not. Okay, this one is less obvious, but this is 3 log 2. I mean, if you think of 3 log 2 as log 2 plus log 2 plus log 2. I mean, that's really what 3 times log 2 means, right? It means we have 3 log 2s. This then is clear, again, by using the product law, because we're adding 3 logs, really we're just multiplying the numbers, right? 2 times 2 times 2. Okay, so that, and you can see 2 times 2 times 2 is 8, and that's why it's equal to log 8. Now, the other way that you can see is, what we can do is, instead of writing 3 log 2 as log 2 plus log 2 plus log 2, you can say that, well, then what we can do is we can bring this constant to the exponent position. So then you can see this is the same thing as log 2 to the power of 3. And this one is log of 3 to the power 4, and 3 to the power 4 is 81. So you can see 2 cubed is 8, 3 to the 4 is 81, and that's the rule, and we call this the power law. okay, is that we can actually move this exponent to the front to become the leading, the coefficient, I suppose. Okay, you can actually bring down the exponent to the front, and that is what we call the power law. Okay, k can be any real number. Okay, so it could be anything. It doesn't have to be whole numbers or negative numbers. It could be fractions as well. Okay. All right. So now we're gonna look at some practice questions here. It says practice or applying the laws of logarithm to logarithms with base 10. Now again, these rules apply to any base. Okay, it does not have to be base 10. It could be any base. But for the first three questions here, we're gonna just use the practice the rules with base 10. Okay, notice that there's no base written here. Again, if it's not written down, it means it's base 10. So this one, I think it's clear. It's a subtraction between two different logs, so we can apply the quotient law, which means this is going to be log of 80 divided by 16, which is log 5. Okay, and I'm just going to leave it there. Okay, I simplify using the log rules, and then that's it. That's all I can do. For the second one, this is addition of two different logs, so then really we can apply the product law, which means we can multiply the 7 with the 8, which is going to be log 56. That's all we can do. Finally, for C, it's 2 log 5. Remember, we can bring the coefficient to the exponent position, so this is going to be log of 5 squared, which is going to be log 25. Okay, so just practice using the laws of logarithm. Okay. All right. Now these are with numbers. Now usually we probably, as you might have expected, we might not see numbers. We might see expressions. So here we have 3 expressions, and we're gonna try to write these expressions as a single logarithm. Okay. So first of all, for part A, we have log x minus 3 log y. So there's a couple of rules that we can apply. There's the minus sign right here, so we can use the quotient rule. However, there's a 3 in the front, and if we go back to the quotient law, there was no coefficient here or there. Okay, so what you got to do first is you actually need to apply the power law first for this. Okay, we have to bring 3 to the exponent position, so this becomes log y cubed. Now, because we're subtracting, we can actually use the quotient law. So this becomes log of x divided by y cubed. Okay, again, subtraction becomes division. Which, if you think about exponent laws, it's the opposite, right? It was if we divide powers with the same base, we subtract exponents. So now we are subtracting, so we divide. Right? That's okay. Anyways, for part B, same thing. I see coefficients here and there and there. So my first step is to apply the power law, which means I can bring the coefficient to the exponent position. So that's 1/3 minus log y squared plus log z cubed. Okay, now the first two is a subtraction. So that means we can combine those two as a fraction because we're dividing them. Y squared. We still have the plus log of z cubed. Okay, now once we finish this, it's a plus sign, or it's addition of two logs. So now we can use the product law, meaning we can actually multiply these two expressions right here. So when you multiply, recall, if you multiply fractions with a whole number, that whole number really just goes to the numerator, and that's it. And that's it. All right, the last one for part C, this one, what we need to do, because it says we need to combine as a single logarithm. Okay, so that's a 3. We can actually rewrite 3 as a logarithm, right? How do we rewrite 3 as a logarithm? Now, when we do that, remember, because this is base 4, you want to make 3 as a log with base 4 as well, okay? So this is going to be log base 4 of something, and plus log base 4 of 2. So I guess the question is, what's this number? Okay, so basically we have this equation that we need to solve. What is this number? So we can always turn this into exponential form. So then we have 4 cubed is equal to this mysterious number. I mean, It's not that mysterious, I guess. 4 cubed is 64, so this number is 64. So we can rewrite this as log base 4 of 64. That is exactly what 3 would equal to in the log form. Now we have both in terms of log and base 4, so now we can actually multiply these two numbers together, and you should get log base 4 of 128. Okay, so that's the examples that I'm showing you. There are 3 questions for you to try, so good luck. All right, so I'll do this quickly. Hopefully you'll get the same answers as I do right here. You should bring the coefficients to the exponent positions, and then because it's addition, so you're going to multiply those two expressions. This one should be log x minus log y cubed plus log z squared. I'm going to do all of them in one step. This is subtraction, so it's going to be x over y cubed. That's an addition, therefore it goes to the numerator. Here's your answer. Finally, this one is going to be log base 2 of 6. 3 is the same thing as log 2 base 8. Log base 2 8. This is going to be log base 2 of 6 over 8, which we can reduce to log base 2 of 3 over 4. Okay, so hopefully those are the answers that you got. Yeah. Okay. Now, what we're going to do is we are going to do the opposite, okay? So it says here, it says practice writing a single log as a sum or difference of logarithm. Okay, so we're going to split them instead now, okay? So you see, these 3 are one single log. Now we're going to split them, okay? So I'll show you the first one and I'll let you try part B and part C. Part C is slightly tricky, but hopefully you'll be able to get it, okay? So I'll show you part A. So again, this is one single log, and you can see it's multiplication of a squared with b cubed. So what we need to do is, because multiplication, we can split this into additions. So it's going to be log a squared plus log b cubed. And once we have that log split into 2 different logs, we can then bring the exponent to the front. So that becomes 2 log a plus 3 log b. Okay, and that will be the answer. So again, like I said, I will let you try part B and part C and see how you do. All right, hopefully you're finished. Let me show you this quickly. This is one single expression. We can split this into log b to the power of 1/3. That's multiplication, so that's going to be addition. So log of a squared, that's a division right there, so it's going to be a subtraction when you split. Okay, so minus log c. Now you can bring the exponent to the front, so you get 1/3 log b plus 2 log a minus log c. Okay. All right, last one. Like I said, this one could be a little bit tricky. I don't know. We'll see. What I would suggest you to do first is to simplify this. Okay, so that's a over b over c. Remember, this line right here means division, right? So this means a divided by b over c. And when you divide fractions, remember you multiply the reciprocal. So this really is ac over b. Okay, really, if you have this done, then it's nothing tricky. Okay, so this is going to be log of ac over b. Now, a times c, therefore it's going to be log a plus log c. That's a division of b, so then we're going to subtract log b. And that will be the answer. Okay. Hopefully you got that. Okay. So last example, or actually a couple more examples is no, last example. I don't know why it says example 4 twice. It should be practice. Okay. Anyways, it says using the laws of logarithms to evaluate the following here. So what we need to do is to combine all the terms into one single log. Okay. So this 2, we can bring it to the exponent position. So that becomes 6 squared minus log base 2 of 9. Now we can simplify this. This is going to be log base 2 of 6 squared. I'm going to change that to 36. That's a subtraction. Therefore, that means we need to divide 9 right here. So this is going to be log base 2 of 36 divided by 9 is a 4. Okay. Now, if you still don't, can't quite evaluate this yet, you need to think about 2 to what power gives you 4. 2 to the power of 2 gives you 4, and therefore log base 2 of 4 is equal to 2. So that's what this equals to. Equals to 2. Okay, part B, similarly, okay, what we're going to do is again, first step is to move the coefficient to the exponent position. 2 to the power 4. And now I am going to write this as one single log. It's base 9, not 4. It's going to be a fraction because I see a subtraction sign right here. This is going to be 2 times 6 cubed, which is 216, divided by 2 to the power 4 is 16. Okay, now you can reduce this. That's, well, I know 16 squared is not 216. Okay, that's, never mind. I can reduce this. That's divided by 2. That's 8. I can, 216 divided by 8 can be divided evenly. So this is going to be 27. Yes, 27. So this really becomes log base 9 of 27. Okay, so now this one is slightly trickier now. Okay, so because what we need to do is, because 9 to any power is not 27. Okay, so what we need to do is we actually need to change this into the exponential form. So really 9 to the power of x is equal to 27. Okay, now because 9 is not the base that we can work with, we need to change these two numbers into base 3. 9 is the same thing as 3 squared. So 9 to the power of x is the same thing as 3 to the power of 2x. You can see 3 squared is 9. 27 is simply 3 cubed, and therefore 2x would have to equal to 3, and therefore x is equal to 3 over 2. Therefore this equals to 3 over 2. That will be the answer. Okay, log base 9 of 27 is equal to 3 over 2. Again, that is because of all of that right there. Okay, I turn this into exponential form and solve it. Okay, so there are the last 2 questions for you to try. Good luck. Okay, again, I'll do it quickly. Hopefully this is what you got. This will be 6 cubed minus log base 9 of 72. This is going to be log base 9 to 16 divided by 72, which is log base 9 of 3. You can again change this into 9 to the power of x is equal to 3. That's going to be 3 to the x equals to 3 to the 1. Therefore, x has to equal to 1/2. So that's the answer. Log base 9 of 3 is equal to 1/2. Okay, I did that quickly. Hopefully you got it already. But again, when you turn it into a log, when you're trying to evaluate log, you should turn it into exponential form and solve it accordingly. Okay. Last question here. Again, first step, I would move the coefficient to the exponent position. That'll be 3 cubed plus log base 12. So now I can combine all the logs to one single term. That's 6 squared is 36 minus, so divided by 3 to the power of 3 is 27, and this is simply 12. Okay, now we can simplify this. This is going to equal to log base 4. Okay, so 36 and 27, I can divide this by 9, so that's a 4, that's a 3. I can divide the 3 and the 12, that's going to be a 1, that's going to be a 4. So this becomes log base 4 of 16. Same thing, you can convert this into exponential form, which will give you 4 to the power of x is 16. I think that one's rather easy. 4 squared is 16, so this equals to 2. Okay, so the key really is for this lesson is to know these rules well, and you need to know when to apply them. Okay, when you see addition of 2 different logs, you just need to multiply the numbers that you're taking the log of, or the expressions, right? When you see subtraction of 2 different logs, then you're dividing them. Or vice versa, right? When you see a division, when you see log of a fraction, you can split them into 2 subtractions of logs. When you have product of a log, you can split them into addition of 2 different logs. Okay, and coefficient can move it to the exponent position or the other way around. exponent can move it to the coefficient. Okay, so that's it for this lesson. Hopefully you understood what's happening here. Let me know if you need some help. Otherwise, good luck with your questions. See ya.